Welcome. This is the frustum of a cone, problem of frustum of a cone, and this diameter of this the base diameter is 50 millimeter and the top diameter is 30 millimeter and height is 45 millimeter is resting upon its base in HP. Draw the isometric projection of the frustum. So that is the problem. So first of all, I will show you the frustum of a cone, a conceptual drawing. See, this is the this is the top diameter. This is the top diameter of the frustum, and this is the bottom diameter of the frustum. So this is the conceptual drawing of the frustum of a cone, and so see, this is the top diameter, this is the top diameter of the frustum, so this is the top diameter. See, this is the top diameter of the frustum is 30 millimeter, and this is 30 millimeter, 30 millimeter. And this bottom portion, this is the bottom diameter. This is the bottom diameter of this frustum, bottom diameter. So this ellipse is the bottom diameter, and this the diameter of this bottom portion, that is base, the base diameter is 50 millimeter. Base diameter is 50 millimeter. Okay, then this height, this is the total height of this object, h. So h is equal to the height of this frustum is 45 millimeter. So this height is 45 millimeter. So our aim is to draw this isometric projection of this frustum of a cone. So I will show you the three-dimensional representation of this. See, you can see this is the frustum of a cone, and this is the top diameter. So in the conceptual drawing, you can see that this top diameter is 30 millimeter. So this is 30 millimeter, and this is the bottom diameter. This is the bottom diameter, and this bottom diameter is 50 millimeter. Then next I will draw the drawing. So first of all, I will select the XY line and then draw a circle. See, this is the top view. So you can see what is the shape of the top view. I will show you. This is this is the top view. See, top view will be two circles. Okay, so draw two circles. So you just draw two circles that represents the top view. So the dimension of this outer circle is 50 millimeter, and this inner circle is, the dimension of this inner circle is, that diameter of this inner circle is 30. So the bottom diameter is 50 and the top diameter is 30. So this is the top view. Then see what is the front view. So So this is the top view. So I just dark this. I just dark these two lines. Okay, so this is the top view. Then I will project this top view and you will get the front view. See, what is the front view? Front view is actually like a trapezium. And what is the height of this trapezium? The height of this trapezium is 45 millimeter. So I just project this. I just project this line. Then also I just project this line. Then I just project this center line. This height of this frustum is 45 millimeter, and then I just project from this point to here, and again I just project a line from this to here. Okay, then I just join this line, then I join this with this line, then I will dark it. This is the front view of the frustum of a cone. Okay, so you know what is the height of this frustum? This height of this frustum is 45 millimeter. Then I will draw the isometric. So this is the top view. This is the top view. So you can see two circles. This is the top view. Then this is the front view. So front view is actually a trapezium. This is the front view. Okay, then I will draw the isometric view. First of all, I just draw a reference line here. Before that, I just draw a box here. So draw a box such that the dimension of this box is the diameter of the outer circle. So the diameter of the outer circle is 50, such that you can see this dimension is 50. Similarly, this dimension is also 50. Okay, then and you just name these 4 boxes as 1, 2, 3, 4. Say, just name this box as 1, this as 2, this point as 3, and this point as 4. Okay, then I just draw a reference line and then mark a point here, and the name of this point is 1. The left bottom end of the point of the box. So you can see this is the point number 1. So that is the first step. Then I will draw 2 lines from this point 1, and the angle of this line is 30 degree. Similarly, I just draw a line from this point, and this angle is 30 degree. Then the length of this line is, see, take this length. What is the length of 1, 2? So you see this length of 1, 2 is 50 millimeter. Multiply this 50 with 0.82. so that value is 41. Okay, so the dimension of this is 41. So 41 means 50 multiplied with the 0.82. Okay, similarly here also the length of this line is 41. Okay, then I just from this point draw a line, and the speciality of this line is parallel to this line. Then similarly from this point draw another line, again this line is parallel to this line, and name the base. So this is 1, so what is this point? This point is 2, and this point is 3, and this point is 4. Okay, then the next step is, say, name the 4 circle points as, say, A, B, C, D. So this is A, and this point is B, and this point is C, and this point is D. So mark 4 points. Okay, see, in this figure you can see that what is the value of 1A. So 1A is, so that this total length is this length is 50. So what is the value of 1A? 1A is 25 millimeter. So multiply this 25 with 0.82. So the value is 20.5. So take that 20.5 and mark here. Mark a point on this here. So this distance is so this distance is 20.5. Similarly mark similarly what is the distance 2B? So 2B is again the center, so this is 25, so multiplied with 0.82 is 20.5. so here also you mark one point, here also you mark one point, here also you mark another point. So this this distance is again 20.5. So this distance is 20.5. Similarly mark this point is 20.5, then this point 20.5. okay, so in 1 2 the name of this point is A, and in 2B 2 3 this point is B. So mark these points. So here this point is capital A, so this is capital A, this is capital B, this point is capital C, and this point is capital D. Okay, then you just draw. See, in the conceptual drawing you can see that this is the bottom side. In the isometric projection of a circle is actually an ellipse, an elliptical shape. So here I will draw an ellipse using 4 points A, B, C, D. So there are 4 points. So here I will draw an ellipse using a method called 4 center method. So first I will take 1 as center and 1 C as radius, draw an arc. So 1 center, 1 C radius, draw an arc C to B. Okay, so 1 center, 1 B radius, draw an arc, and you just dark this CB. Then you just consider this 3 as the center point and 3D as radius, draw an arc. So 3 center, 3D radius, draw an arc, this 3 as center, okay. So 3 as center and 3D as radius, draw an arc AD. Then the next step is join 1C and 3D. You will get an intersecting point. So this point as center, and this C as radius, draw an arc CD. Okay. Then similarly join this 1 and B, join this 1 and B, then 3 and A. Then this intersecting point as center and this as radius, this intersecting point as center and this distance radius, draw an arc. Okay, so you will get an ellipse ABCD. Okay, so here you will get the base. So this is the base. Then what is the next step? Next step is draw the top. Okay, so for that you just draw 4 perpendicular, 4 vertical lines from this 4 points. So this draw from 4, draw a line. Similarly from 3, draw another line. Then from 2, draw another line. Then from 1, draw another line. So draw 4 lines. So what is the height of this vertical line? So in the conceptual drawing you can see what is the height of this frustum of a cone. So the height of the frustum of a cone is 45. So you just 45 multiplied with 0.82. So that value is 36.9. So this height of this vertical line is 36.9. Okay. Similarly, the height of this is 36.9. This is 36.9, and this is 36.9. Okay. Then you just join all these 4 points. Okay, so join all these 4 points. So this is the top face of this box. Okay, so you can see this this frustum of a cone is we placed this frustum of a cone in a box. So then the next step is mark this circular points on the top face. So for that what I do is, again I will draw another rectangle. So draw a rectangle like this. Okay, and then you just extend this rectangle to here. Okay, and I just name this rectangle as, say, 5, 6, 7, 8. So this is 5, this point is 6, this point is 7, and this point is 8. So 5, 6, 7, 8. Okay, then I will measure this distance. So this distance is actually 10. Okay, so multiplied that 10 with 0.82, so the value is 8.2. Okay, So mark this 8.2 here. So mark a point here, and this distance is 8.2. 8.2. Similarly, you just mark all other points here. So here you mark 1 point, 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 here and here. So all the distance is what is the distance? It is 8.2. So mark the dimension, it is 8.2. so this is 8.2. then here it is 8.2. then here it is 8.2. then here it is 8.2, and here it is 8.2, and here it is 8.2, and here it is 8.2. Okay, so then what is the next step is join the opposite points using straight line. So this join this then this point with this point, then this point with this point, this point with this point. So now you can see there are 4 intersecting points, and these 4 intersecting points are the 5, this point is 5, this point is 5, and this point is 6, and this point is 7, and finally this point is 8. So here you can see the 4 points 5, 6, 7 and 8. So in 5, 6 you can see this this point. So what is the diameter, what is the diameter of this smaller circle? So the diameter of this, the top diameter of this smaller circle is 30 millimeter. Okay, so this from point 5 to this center point, so the distance is, it is the radius, so it is 15 millimeter. So you just 15 multiplied with the 0.82, so the value is 12.3. okay, so I just mark point here, mark a point here, and this distance is and this so this distance is 12.3. okay, then here also you just mark another point in on 6, 7, again that is 12.3. from this point to this point, this distance is 12.3. here also this distance is 12.3, and finally in this point in the here this distance is 12.3. okay, then you can apply the 4 center method, the previous method. So this as center and this as radius, draw an arc. So this as the center point, and this is radius, draw an arc. Similarly, this as center, this distance as radius, draw another arc. Then draw a straight line from this point to this point, then from this point to here you will get an intersecting point. Okay, so this intersecting point as center, you just draw arc here. So this intersecting point as, okay. Similarly here also you just draw a straight line connecting these 2 points. Take line command and then draw a straight line here, then draw a straight line to here. So you will get the intersecting point, this intersecting point. So this intersecting point as center, draw an arc here. So you will get another ellipse. You just dark this ellipse. Okay, so okay, so you can see there are 2 ellipses. So here this is the bottom ellipse and this is the top ellipse. Okay, so what is the next step? Connect these 2 ellipses using straight line. Okay, so you just connect these 2 ellipses using straight line. So this is the isometric projection of a frustum of a cone. In this way you can draw this isometric projection of a frustum of a cone. So this is the isometric projection. This is the isometric projection. Okay, so I will explain the steps once again. So first you draw the top view. So top view will be 2 circles. So you can see top view will be 2 circles, one outer circle and one base circle, and of diameter 50 mm, and the top circle it is 30 mm. Then draw the front view. So you can see the front view. The front view is actually a trapezium. So this is the trapezium of height. So what is the height of this trapezium? Height of this trapezium is 45 mm. So draw the front view. Then draw the box, and then you just draw the box, outer box, and then transfer all these points to the bottom face and the top face. Then apply force center method to draw one ellipse at the bottom and one ellipse at the top. Then connect these 2 ellipses using straight line. So you will get the you will get the isometric projection of the frustum of a cone. So here you can see all the values you just multiplied with 0.82. So that means this shape is 82% only, reduced by 82%. So that is very important. So multiplied all these dimension values with the 0.82. So in this way you can draw the isometric projection of the frustum of a cone. So this is the isometric projection, and this is the 3D view. Okay, for understanding. So this is the 3D view, and this is the conceptual drawing. Okay, thank you.